Much of what you call your personality is, in practice, a set of repeated actions that sank beneath awareness and became automatic. The way you reach for coffee before speaking in the morning, the route your hand traces to the light switch in a dark room, the subtle shift in your posture when you sense tension in a conversation. These are not choices you make. They are choices that were made so many times they dissolved into reflex, into identity, into the quiet architecture of who you are. And tonight, as your body settles and your thoughts begin to soften, we are going to trace the science of how that happens, how repetition becomes ritual, and ritual becomes self. Welcome to Let's Learn While You Sleep. Tonight, we are turning inward, past the skin, past the bone, into the soft folds of the brain where your habits live, not as thoughts exactly, but as well-worn grooves in a landscape of neural tissue. Imagine, if you will, a field of fresh snow. The first time you walk across it, you leave a faint trail. The second time, the path is easier to find. By the 100th crossing, there is no question where to step. The groove has become a channel, and the channel has become a road. This is, in essence, what neuroscience has revealed about habit formation. Deep within the brain, a small curved structure called the basal ganglia quietly takes note of which actions you repeat, and it begins to automate them, freeing your conscious mind for other things. Tonight, we will explore how these loops are built, how sleep itself strengthens and reshapes them, and how the person you are becoming is sculpted not only by what you do while awake, but by what your sleeping brain decides to keep. So let your shoulders drop, let your breath slow. The science is gentle tonight, and there is nowhere else you need to be. To understand how a habit forms, we must first understand a remarkable piece of neurological architecture, the habit loop. In the 1990s, researchers at the Massachusetts Institute of Technology, working with laboratory rats, discovered something that would reshape our understanding of behavior. They placed rats in a simple T-shaped maze with chocolate at one end. At first, the rats would wander, sniff, scratch at the walls, and eventually, almost by accident, stumble upon the reward. Their brains during those early trials were ablaze with activity, the prefrontal cortex working overtime, the sensory regions firing rapidly, every turn generating a cascade of new information. But as the rats repeated the maze, something extraordinary happened. The neural activity began to quiet, not because the rats stopped performing the task, but because the task was migrating, moving from the conscious, deliberative regions of the brain into a deeper, older structure known as the basal ganglia. The basal ganglia sit near the center of the brain, nestled at the base of the forebrain. They are evolutionarily ancient, present in reptiles, in birds, in every mammal that has ever lived, and their primary contribution to behavior is this: they chunk sequences of actions into single automated units. Neuroscientists call this process chunking. When you first learned to tie your shoes, each loop and pull required your full attention. Now, the entire sequence fires as a single neural package, triggered by the sight of an untied lace. The habit loop, as described by researchers, consists of three components: a cue, which is the trigger that initiates the behavior, a routine, which is the behavior itself, and a reward, which is the outcome that tells the brain this loop is worth preserving. Every time you complete this cycle, the connection between cue and routine strengthens slightly, like a path worn deeper into the snow. and the basal ganglia, ever attentive, ever patient, file that loop away into a kind of neural shorthand. The conscious mind no longer needs to supervise. The habit has, in a real and measurable sense, dropped below the surface of awareness. It runs like a background process on a quiet machine. Now, here is where the story deepens, because it is not only during your waking hours that these loops are strengthened. Some of the most critical work of habit consolidation happens while you sleep. During the day, when you practice a new skill or repeat a behavior, the brain creates what neuroscientists call a memory trace, a fragile temporary pattern of neural activation held primarily in the hippocampus, a seahorse-shaped structure tucked deep within the temporal lobe. The hippocampus is extraordinary at rapid learning. It can encode a new experience in a single exposure, but it is not designed for permanent storage. Think of it as a notepad, quick, flexible, but easily overwritten. For a memory trace to become durable, it must be transferred to the neocortex, the brain's vast outer layer, where it can be woven into the existing fabric of long-term knowledge. This transfer process is called memory consolidation, and it occurs predominantly during sleep, particularly during the deep, slow-wave stages of non-REM sleep. In the early 2000s, researchers at the University of Lübeck in Germany demonstrated that subjects who slept after learning a hidden shortcut in a number sequencing task were more than twice as likely to discover the shortcut consciously upon waking compared to subjects who remained awake for the same duration. Sleep had not merely preserved the memory, it had reorganized it, extracting the underlying pattern and making it accessible in a new way. During slow-wave sleep, the brain generates large, synchronized electrical oscillations, slow waves that sweep across the cortex like tides. Within these slow waves, the hippocampus replays the day's experiences in compressed bursts called sharp wave ripples, which occur at approximately 100 to 200 milliseconds in duration. These ripples carry the encoded memory traces from the hippocampus to the neocortex, where they are gradually integrated into stable, long-lasting networks. Each night, as you lie still and unaware, your brain is quietly replaying the loops you practiced during the day, testing them, reinforcing them, and deciding which ones deserve to be kept. It is a kind of curation, slow and unconscious, performed in the deep silence between dreams. Consider, for a moment, the neurotransmitter dopamine. It is often described in popular culture as the brain's pleasure chemical, but this description, while not entirely wrong, is incomplete. Dopamine's deeper role is in prediction and motivation. It signals not merely that something felt good, but that something was better than expected. Or, crucially, that a familiar cue now predicts a reward that is coming. In the 1990s, the neuroscientist Wolfram Schultz, working at the University of Fribourg in Switzerland, recorded the activity of dopamine neurons in monkeys performing simple reward tasks. What he found was revelatory. At first, dopamine fired when the monkey received the reward, a squirt of juice. But after many repetitions, the dopamine response shifted. It no longer fired at the moment of reward. Instead, it fired at the moment of the cue, the sound or light that predicted the reward was coming. The anticipation had become the event. This is a fundamental mechanism of habit formation. Once a behavior has been repeated enough times, the brain no longer waits for the reward to feel satisfaction. The mere appearance of the cue triggers a dopamine surge, which drives the routine forward almost automatically. You do not decide to reach for your phone when you hear the notification sound. The cue fires, dopamine flows, and the hand moves before the conscious mind has fully registered what is happening. And yet, this dopamine-mediated learning does not end when you close your eyes. Research published in the journal Nature Neuroscience has shown that dopamine neurons remain active during certain phases of sleep, particularly during REM sleep, when dreaming is most vivid. Some researchers propose that this sleeping dopamine activity may help the brain evaluate which habit loops produce the most meaningful rewards, strengthening those pathways and allowing others to gradually weaken. It is as though the sleeping brain runs a kind of audit, reviewing the ledger of the day's actions and quietly marking which ones earned their keep. The habits that survive this nightly reckoning are the ones that edge closer to permanence, closer to the feeling of being not something you do, but something you are. There is a structure in the brain that deserves special attention in our story tonight, and that is the striatum, a component of the basal ganglia that serves as a kind of gateway between intention and automation. The striatum receives input from nearly every region of the cortex, as well as from the dopamine-producing neurons of the midbrain. It integrates these signals to help the brain select which action to perform next. In the early stages of learning a new behavior, the dorsomedial striatum is most active. This is the part associated with goal-directed actions, the kind that require you to think carefully about what you are doing and why. But as repetition continues, activity gradually shifts to the dorsolateral striatum, which is associated with habitual, stimulus-driven behavior. This migration from medial to lateral striatum has been observed in both animal studies and human neuroimaging research. It is the neural signature of a behavior transitioning from something you choose to something that simply happens. And here is what makes this relevant to the sleeping mind. Studies using functional magnetic resonance imaging have shown that the striatum is reactivated during sleep, particularly during the sleep spindles, brief bursts of oscillatory brain activity at approximately 12 to 16 Hz that punctuate the lighter stages of non-REM sleep. Sleep spindles are generated by the thalamus and are believed to play a critical role in the consolidation of procedural memories, the kind of memories that underlie physical skills, routines, and yes, habits. Research led by teams at the University of Montreal and other institutions has demonstrated that individuals who produce more sleep spindles following a motor learning task show greater improvement in performance the next day. The sleeping brain, it seems, is not merely resting, it is rehearsing. It is running the loops again and again in miniature, like a musician practicing scales in a dream. And with each nocturnal rehearsal, the pathway through the striatum becomes a little more automatic, a little more invisible, a little more like something that simply belongs to you, as natural and unremarkable as breathing. Let us pause here in this soft stretch of the night and consider something both humbling and wondrous, the sheer volume of your behavior that operates below conscious control. Researchers at Duke University published a paper in 2006 estimating that approximately 40% of the actions people perform each day are not the result of active decisions, but of habits. 40%. Nearly half of everything you do on any given day, from the sequence in which you wash your body in the shower, to the words you use to greet a coworker, to the slight tightening of your jaw when you open your email. These are automated scripts running on neural hardware that was wired through repetition and refined through sleep. And yet, we rarely notice. This is, in fact, one of the defining features of a well-formed habit. It becomes invisible to the person performing it. The psychologist William James, writing in his landmark 1890 work, The Principles of Psychology, described habit as the flywheel of society, its most precious conserving agent. He understood, even before the tools of modern neuroscience existed, that the purpose of habit was to free the higher mind from the burden of routine so that attention and willpower could be directed toward novel challenges. The basal ganglia do not care whether a habit is good or harmful. They are not moral structures. They are efficiency engines designed to detect repetition and automate it. This is why breaking a habit can feel so profoundly difficult. You are not simply choosing to act differently. You are working against a neural pathway that has been physically strengthened by months or years of repetition and nightly consolidation. The myelin sheaths that insulate frequently used axons grow thicker with use, allowing electrical signals to travel faster. The synaptic connections between the neurons involved in the habit loop become more numerous and more sensitive to the trigger. The groove in the snow has become, over time, something closer to a canyon. And it is in that canyon that much of your daily life quietly flows, unseen, unfelt, but profoundly shaping the person you present to the world each morning. There is another dimension to this process that deserves our quiet attention tonight, and that is the role of emotion. Habits are not formed by repetition alone. They are formed by repetition that carries emotional weight. The amygdala, a small almond-shaped cluster of nuclei located deep within the temporal lobes, plays a central role in tagging experiences with emotional significance. When an action is followed by a strong emotional response, whether pleasure, relief, comfort, or even fear, the amygdala strengthens the associated memory trace, making it more likely to be consolidated during sleep. This is why habits formed during periods of stress or emotional intensity tend to be especially durable. The person who begins smoking during a difficult time in their life is not simply learning a motor sequence. They are encoding a loop that is saturated with emotional relief, the cue of stress, the routine of reaching for a cigarette, the reward of momentary calm. The amygdala ensures that this loop is flagged as important, and during subsequent sleep, the memory consolidation system treats it with priority. Research has shown that emotionally charged memories are preferentially consolidated during REM sleep, the stage most associated with vivid dreaming. During REM, the prefrontal cortex, the seat of rational oversight, is relatively quiet, while the amygdala and other limbic structures are highly active. Some researchers believe that this configuration allows the brain to process emotional memories in a unique way, stripping away some of the raw emotional intensity while preserving the informational content. This may be why a painful memory can, over time and over many nights of sleep, begin to lose its sting while the lessons it carried remain intact. For habits, this means that the emotional fuel that initially powered the loop may gradually fade, but the behavior itself, now automated, now lodged in the striatum, persists. The emotion was the kindling. The habit is the fire that learned to sustain itself. And so, as you lie here tonight, know that your sleeping brain is not only replaying actions, it is replaying feelings, deciding which emotional echoes to preserve and which to gently dissolve into the quiet warmth of forgetting. Now, let us travel deeper into the night, into the architecture of sleep itself, and examine the specific stages that contribute most to the consolidation of habit loops. Sleep is not a single uniform state. It is a cycle, a repeating sequence of stages, each with its own characteristic brainwave patterns and physiological signatures, recurring approximately every 90 minutes throughout the night. The first two stages of non-REM sleep are relatively light. Brain activity slows, muscles relax, and the thalamus begins to gate incoming sensory information, gradually sealing the conscious mind away from the outside world. It is during stage 2 non-REM sleep that we encounter those remarkable sleep spindles. The 12 to 16 Hz oscillatory bursts we discussed earlier, which appear to play a vital role in motor learning and procedural memory consolidation. As sleep deepens into stage 3, we enter slow-wave sleep, characterized by large synchronized delta waves oscillating at roughly half a hertz to 4 Hz. This is the deepest stage of sleep, the hardest to wake from, and it is here that the hippocampus and neocortex engage in their most intensive dialogue. The slow oscillations create alternating periods of neural silence, called down states, and intense coordinated activity, called up states. During the up states, hippocampal sharp-wave ripples fire in synchrony with thalamocortical spindles, creating a precise temporal window in which memory traces can be transferred from temporary hippocampal storage to the enduring networks of the neocortex. Researchers sometimes describe this as a triple coupling mechanism: slow oscillations, spindles and ripples working together like gears in a finely tuned clock. Later in the night, as the cycles progress, REM sleep becomes more prominent. REM sleep brings a different kind of processing, more emotional, more creative, more integrative. It is during REM that the brain appears to find connections between newly consolidated memories and older ones, weaving new habits into the broader tapestry of existing knowledge and behavior. Each stage contributes something irreplaceable, and when sleep is disrupted or shortened, the consolidation process suffers, and the habits you practiced during the day may fail to take root as deeply as they otherwise would. There is a beautiful subtlety in the way the brain decides what to consolidate and what to let go. Not every repeated action becomes a lasting habit. Not every loop survives the night. The brain, for all its vast capacity, operates under constraints of energy and storage, and it must be selective. Current evidence suggests that the brain uses several signals to determine which memory traces deserve consolidation. One of the most important is reward prediction error, the dopamine-mediated signal we discussed earlier, which marks experiences that were unexpectedly rewarding. Loops that produced outcomes better than anticipated receive a neurochemical stamp of significance, making them more likely to be replayed and strengthened during sleep. Another signal appears to be the expectation of future relevance. In a striking series of experiments conducted at the University of Lübeck, researchers told some participants that they would be tested on material the following day, while telling others that the test had been cancelled. Both groups slept. But only the group that expected to be tested showed robust memory consolidation for the material. Somehow, the brain had used the mere intention of future use as a filter, prioritizing memories that the waking mind had flagged as important. This finding suggests that the consolidation process is not entirely automatic or passive. It is influenced by your goals, your expectations, and perhaps even the quiet narrative you tell yourself about who you are trying to become. If you spend your evening practicing a new skill with genuine intention and attention, you're not merely strengthening the neural pathway through repetition, you're also sending a signal to the sleeping brain that this loop matters. You are whispering to the consolidation machinery, this one is worth keeping. And somewhere in the deep hours of the night, while you dream of things you may never remember, the machinery listens. The hippocampus replays, the spindles fire, and the loop sinks a little deeper into the fabric of who you are. Not because it was forced there, but because something in you quietly asked it to stay. Let us turn now to a question that hovers at the edge of all this science, the question of identity. At what point does a repeated behavior stop being something you do and start being something you are? This is not merely a philosophical puzzle. It has neurological dimensions that are only now beginning to be understood. When a habit is new, it is encoded in circuits that are flexible and context-dependent. The dorsomedial striatum, working closely with the prefrontal cortex, evaluates each performance of the habit against current goals and expectations. You are aware of the behavior. You can modify it. You can stop it if circumstances change. But as the habit matures and migrates to the dorsolateral striatum, something fundamental shifts. The behavior becomes insensitive to changes in the outcome. In laboratory experiments, rats that had extensively practiced a lever-pressing habit continued to press the lever even after the food reward had been devalued, made nauseating, through a procedure called outcome devaluation. Goal-directed rats, whose habits were still young, immediately stopped pressing, but the habitual rats persisted. Their behavior was no longer connected to the outcome. It was connected to the cue. This phenomenon, known as habit insensitivity to outcome devaluation, has been replicated in human studies as well. It reveals something profound about the nature of deeply ingrained habits. They are, in a very real sense, autonomous. They do not need your permission to execute. They do not require your ongoing approval. They simply run when triggered, like a reflex, like blinking, like the beating of your heart. And this is why, over time, habits begin to feel less like choices and more like personality. When someone describes themselves as a morning person or a worrier or someone who always arrives early, they are not usually describing a conscious philosophy. They are describing a set of deeply automated loops that have been running for so long, through so many nights of silent consolidation, that the boundary between the habit and the self has become impossible to find. The behavior and the identity have merged slowly and quietly, like two rivers joining in the dark. And yet, the story does not end with permanence. One of the most encouraging discoveries in modern neuroscience is that habits, even deeply entrenched ones, are not truly fixed. They can be rewritten. The process is not simple, and it is not fast, but it is real. And it too depends on sleep. Researchers studying habit reversal have found that the original habit loop is rarely erased entirely. Instead, a new loop is built alongside it, a competing pathway that, with sufficient repetition and reward, can eventually override the old one. This is sometimes called the dual process model of habit change. The old loop remains stored in the basal ganglia, which is why people who have quit smoking for years can feel a sudden, powerful urge when they encounter a familiar cue: the smell of smoke, the stress of a difficult meeting, the particular time of evening when they once reached for a cigarette. The old loop is still there. It has simply been overridden by a newer, stronger one. Sleep plays a critical role in this overriding process as well. Studies have shown that new habit loops, like old ones, are consolidated during sleep through the same mechanisms of hippocampal replay, spindle-mediated transfer, and slow-wave integration. The brain does not distinguish between a first habit and its replacement. It consolidates whatever has been most recently and most emotionally reinforced. This means that the same nightly process that once hardened the unwanted habit into identity can now be recruited to build something different. Each night of sleep after practicing a new behavior is an opportunity for that behavior to sink a little deeper, to gain a little more traction against the older pathway. It is a slow process, measured in weeks and months rather than days. But it is real, and it is happening inside you right now, whether you are aware of it or not. The brain is not fixed. It is fluid. It is being rebuilt in the dark, gently and continuously, by the same quiet mechanisms that built everything you are. And that, perhaps, is the most comforting thought one can carry into sleep. Somewhere in the middle of the 20th century, a Canadian psychologist named Donald Hebb proposed an idea that would become one of the foundational principles of neuroscience. He suggested in his 1949 book, The Organization of Behavior, that when two neurons fire together repeatedly, the connection between them is strengthened. This principle, often summarized as neurons that fire together wire together, has been confirmed and elaborated upon by decades of subsequent research. And it lies at the very heart of habit formation. Every time a habit loop fires, cue, routine, reward, the neurons involved in that circuit activate in sequence. With each activation, the synaptic connections between them become marginally stronger. Proteins are synthesized, receptor densities shift, and the myelin sheath that insulates the axon grows incrementally thicker, increasing the speed at which the electrical signal travels. Over hundreds of repetitions, these small changes accumulate into something substantial. The pathway becomes, in neural terms, a preferred route, a circuit that fires faster, more reliably, and with less energy than competing alternatives. This is why habits feel effortless once established. The neural cost of running a well-worn loop is dramatically lower than the cost of making a novel decision, and during sleep, this wiring process continues. Long-term potentiation, the molecular mechanism by which synaptic connections are strengthened, is facilitated during slow-wave sleep, when levels of cortisol are low and the cellular environment is conducive to protein synthesis and structural remodeling. The brain, unburdened by the demands of wakefulness, can devote its resources to the physical construction of the pathways that will carry tomorrow's automatic behaviors. Think of it as a road crew working through the night, paving and widening the routes that saw the most traffic during the day. By morning, the road is smoother, the journey faster, and the driver, your conscious mind, barely needs to steer. This is the physical reality of habit. It is not metaphor. It is concrete, measurable, built from molecules and electricity and the patient work of sleeping neurons. There is one more layer to this story that we should explore before the night deepens further, and it concerns the relationship between habits and the default mode network, a constellation of brain regions that becomes active when your mind is at rest, when you're not focused on any particular task, when you are simply being. The default mode network, or DMN, includes areas such as the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus. It is associated with self-referential thinking, the kind of thinking that constructs your sense of who you are, what you value, and how you relate to the world. Researchers have observed that the DMN becomes active during periods of mind wandering and during certain phases of sleep, particularly during lighter sleep stages and REM sleep. Some neuroscientists propose that the DMN may play a role in integrating newly consolidated habits into the broader self-narrative. The ongoing story your brain constructs about who you are. When a behavior becomes automatic enough to be handled by the basal ganglia without conscious supervision, it frees up cortical resources, and some of those resources may be redirected toward the DMN's self-reflective processes. In other words, as a habit drops below awareness, the brain may simultaneously update its model of you to include that habit as a feature of identity rather than a deliberate action. This is still an area of active research, and we should be careful not to overstate what is known. But the possibility is tantalizing that the sleeping brain does not merely consolidate habits in isolation, but weaves them into the larger tapestry of self-understanding. That the person you feel yourself to be each morning is not merely a collection of memories and habits, but an actively constructed narrative, revised and updated each night by the quiet interplay of hippocampal replay, striatal automation, and the self-reflective whisper of the default mode network. You are, in a very real sense, rewritten in your sleep. And the ink is made of dopamine and slow waves and the gentle, repeated rhythms of a life lived one loop at a time. As the night stretches on, let us hold one final thought, a thought about gentleness, about patience, about the tender slowness with which real change occurs. Our culture often speaks of transformation in dramatic terms, breakthrough moments, sudden awakenings, the instant when everything changes. And while such moments do exist, the neuroscience of habit tells a quieter story. It tells us that the person you are becoming is being built not in a single flash of insight, but in thousands of small repetitions, each one barely noticeable, each one laying down another thin layer of myelin, another fractional adjustment of synaptic strength, another night of silent consolidation. This is how the brain works. Not through revolution, but through accumulation. The pianist who plays a passage 10,000 times does not improve in a single dramatic leap. She improves in 10,000 tiny increments, many of them occurring while she sleeps, as her brain replays the finger movements and strengthens the motor circuits that will make tomorrow's performance fractionally smoother than today's. The meditator who sits each morning does not achieve stillness through a single act of will. She achieves it through the gradual automation of attentional habits, the loop of noticing distraction, returning to the breath, and feeling the subtle reward of presence. Repeated so many times that the mind begins to settle, not because it is told to, but because the pathway is worn deep enough that settling has become the path of least resistance. And this is perhaps the most important thing to carry with you into sleep tonight, that every small, repeated action matters. Not because each one is powerful on its own, but because each one is a signal to the sleeping brain, a quiet instruction that says, "This is what I am practicing. This is what I am becoming. This is the loop I choose." The brain will listen. It always does. It will replay the loop in the dark. It will strengthen the pathway, and over weeks and months and years, the habit will sink so deep that it will become indistinguishable from you. Not because it forced its way in, but because you invited it gently, one repetition at a time. And so we arrive at the edge of understanding, where science meets the soft unknown. We know that habits are built through repetition. We know that the basal ganglia automate them. We know that dopamine marks which loops are worth preserving, and that the amygdala adds the weight of emotion. We know that sleep, with its slow waves and sharp wave ripples and spindles, consolidates these loops into the physical architecture of the brain. We know that the striatum shifts from goal-directed to habitual processing. And we know, or at least we suspect, that the default mode network helps weave these automated behaviors into the narrative of self. But what we do not yet fully understand is the precise mechanism by which a behavior crosses the threshold from something you do to something you are. We do not know exactly when the conscious mind releases its grip and the habit becomes truly autonomous. We do not know whether there is a critical number of repetitions, a critical number of sleep cycles, or whether the transition is more fluid than any sharp boundary could describe. These remain open questions, the kind that make neuroscience both humbling and endlessly fascinating. What we can say is this, that you are not a fixed thing. You are a process, ongoing and dynamic, shaped by every action you repeat and every night of sleep that follows. The habits you carry are not chains. They are pathways, worn by your own footsteps, and they can be redirected slowly and gently by the same mechanisms that created them. Tonight, your brain will do what it has done every night of your life. It will review the day, replay the loops, and build a little more of the person you are becoming. You do not need to supervise this process. You do not need to understand every detail. You need only rest and trust that the quiet machinery of sleep knows its work. It has been doing this for as long as there have been brains to sleep in, and it will continue long after the last question has been answered. Consider for a moment the quiet architecture of forgetting, because forgetting is not the enemy of habit, but rather its silent partner, its most essential collaborator in the long work of shaping who you become. Each night, as the brain replays the loops it has chosen to strengthen, it simultaneously loosens the connections that support competing patterns, the hesitations, the alternative responses, the older versions of yourself that once governed your behavior. This process, which neuroscientists sometimes call synaptic downscaling, was described in detail by Giulio Tononi and Chiara Cirelli at the University of Wisconsin-Madison. Their synaptic homeostasis hypothesis, proposed in the early 2000s, suggests that during waking hours, synapses throughout the cortex tend to grow stronger as we learn and experience the world, and that slow-wave sleep serves as a period of global recalibration, gently reducing synaptic strength across the board so that the most important connections, those reinforced by repetition, by emotion, by relevance, stand out more clearly against a quieter background. Imagine a field of snow in which thousands of footprints have been pressed throughout the day, some deep and deliberate, others faint and accidental. Overnight, a soft new layer of snow falls, covering the shallowest impressions entirely, while the deepest paths remain visible, even more distinct now against the fresh white surface. That is something like what happens inside your sleeping brain. The habits you have practiced most faithfully, the loops you have traveled most often, retain their depth and clarity, while the distractions, the false starts, the behaviors you tried once and abandoned, fade gently into the neural background. And so forgetting is not loss. It is curation. It is the brain's way of saying this matters and this does not, at least not anymore. Without this nightly editing, your neural landscape would become cluttered beyond use, every impulse equally loud, every memory equally vivid, every possible response competing for attention at every moment. Sleep protects the signal by reducing the noise, and in doing so, it allows your habits to emerge not as one option among many, but as the clear and quiet default. The path your mind follows when no other instruction is given. And yet there is something even more remarkable happening during these sleeping hours, something that reaches beyond the mechanics of individual synapses and into the realm of identity itself. Because when we speak of habits, we often think of them as things we do. Brushing teeth, reaching for a glass of water, sitting down to write, choosing the stairs instead of the elevator. But over time, as these loops are consolidated and pruned across hundreds and then thousands of nights, they cease to be merely actions. They become traits. They become character. They become the answer to the question of who you are. Psychologists who study self-concept have long noted that identity is not something we decide once and carry forward unchanged. It is constructed continuously, assembled from the evidence of our own behavior, from the stories we tell ourselves about what we repeatedly do. The philosopher William James wrote in his Principles of Psychology, published in 1890, that habit is the enormous flywheel of society, its most precious conservative agent, and he understood even then that what we do habitually is what we become fundamentally. The sleeping brain participates in this transformation in a way that waking consciousness cannot. During the day, you may doubt yourself, question your choices, wonder whether the new behavior is really you or merely an effort, a performance, a temporary departure from your true nature. But at night, the prefrontal cortex, that seat of self-conscious deliberation, grows quiet, and the deeper structures of memory do their work without the interference of doubt. They do not ask whether the habit belongs to you. They simply weave it more tightly into the fabric of your neural architecture, connecting it to emotional memories, to spatial contexts, to the body's own sense of rhythm and readiness. And when you wake, the habit feels slightly less like something you are trying to do and slightly more like something you simply are. This is the alchemy of sleep. Not that it changes you overnight, but that across many nights, it translates the language of effort into the language of being, one quiet consolidation at a time. There is a gentleness to this process that deserves our attention, because so much of our waking relationship with habits is colored by harshness, by frustration at our own inconsistency, by the sense that we are failing when we stumble, that every lapse is proof of some fundamental weakness. But the sleeping brain does not operate in the language of failure. It does not punish. It does not judge. It simply works with whatever material you have given it during the day, strengthening what was practiced, softening what was not, following the same patient principles it has followed since you were an infant, learning to reach for objects, to crawl, to form your first uncertain words. Research on motor learning has shown that even a single practice session, even an imperfect one filled with errors and corrections, provides the raw material that sleep can refine. A study published in 2010 by Matthew Walker and colleagues at the University of California, Berkeley, found that participants who practiced a motor sequence and then slept showed not only better speed, but also fewer errors upon retesting, suggesting that sleep does not merely preserve a memory of the practice. It actually improves upon it, smoothing the rough edges, extracting the essential pattern from the noise of trial and error. And so, if you have spent this day trying, even imperfectly, to build a new habit, to respond differently in a familiar situation, to choose a path that feels uncertain and effortful, then you have done something profoundly meaningful. You have laid down the raw traces that this very night, during the slow oscillations and the spindle bursts and the quiet orchestration of your sleeping brain, will be refined and strengthened and woven a little more securely into the architecture of your behavior. You do not need to be perfect in the attempt. You need only to attempt and then to rest, and to trust that the ancient machinery of consolidation will do what it has always done, quietly, faithfully, without any need for your conscious supervision, turning effort into ease across the long, unhurried hours of the night. Let us linger here at the threshold between understanding and surrendering to rest, and consider one last mystery: the question of why habit formation feels so different from the inside than it looks from the outside. From the outside, building a habit appears to be a story of willpower, of discipline, of forcing yourself to repeat the same action day after day until it finally sticks. And there is some truth in that description, at least for the waking portion of the process. But from the inside, from the perspective of the brain itself, the story is entirely different. It is a story of waves and rhythms, of electrical oscillations sweeping across the cortex in patterns that have been refined across hundreds of millions of years of evolution, long before human beings ever thought about habits at all. The thalamocortical circuits that generate sleep spindles are among the oldest functional architectures in the mammalian brain. They are present in rats and cats and primates, and in species that diverged from our lineage tens of millions of years ago. And the hippocampal replay that reactivates waking experiences during sleep has been observed in rodents navigating mazes, in songbirds rehearsing their melodies, in organisms that have no concept of self-improvement and no ambition beyond survival. What this tells us is something humbling and, in its own way, deeply comforting. The machinery that builds your habits while you sleep is not something you invented. It is not something you must earn or activate through sheer force of will. It is your birthright as a creature with a sleeping brain, an inheritance passed down through an unbroken chain of ancestors who survived precisely because their brains could learn from the day and consolidate that learning through the night. And so, as you lie here now, feeling the gentle weight of your body against the surface beneath you, feeling your breath settle into its own slow and natural rhythm, you can release the burden of effortful control. The work of this day is done. The traces have been laid, and now the oldest, most patient part of your mind is preparing to do what it does best, to take what you have practiced, to refine it, to weave it quietly into the fabric of who you are becoming. Consider for a moment what happens when a habit has been rehearsed so many times that it no longer lives in the parts of the brain responsible for deliberate thought. Neuroscientists have observed that as a behavior becomes truly automatic, its neural signature migrates away from the prefrontal cortex, that region behind your forehead associated with planning and conscious decision-making, and settles deeper into the basal ganglia, a cluster of structures nestled near the very center of your brain. The basal ganglia are ancient in evolutionary terms, shared across mammals, birds, and even reptiles, and they specialize in selecting and executing well-practiced sequences of action without requiring the slow, energy-expensive oversight of conscious awareness. This migration is not a single event, but a gradual transition, and sleep appears to be one of the most powerful catalysts for completing it. During slow-wave sleep, the coordinated replay of a habit's neural pattern allows the cortex to release its grip on the sequence, passing the instructions downward, deeper, into subcortical territory where they can be stored more efficiently and triggered more rapidly. It is as though the brain, in its infinite patience, recognizes that some patterns have proven themselves trustworthy enough to be automated, freeing the conscious mind for newer, less familiar challenges. And yet, this transfer carries a subtle consequence, because once a habit has been fully absorbed into the basal ganglia, it becomes remarkably resistant to change. This is why habits that have been practiced for months or years can feel almost impossible to break through willpower alone. The conscious mind, which once held the blueprint, has long since handed it off, and reclaiming control requires building an entirely new, competing pattern, strong enough to override the old one. Sleep, in this way, is both the architect of effortless skill and the quiet guardian of deeply rooted routines, consolidating whatever patterns we have chosen to repeat without judging whether those patterns serve us well or poorly. The sleeping brain does not distinguish between a habit that brings health and one that brings harm. It only recognizes repetition, consistency, and the emotional weight that accompanies each loop through the cycle. This brings us to something deeply personal, something that reaches beyond the mechanics of neurons and into the territory of who we understand ourselves to be. Because when a behavior has been repeated enough times, consolidated enough nights, and embedded deeply enough into the automatic architecture of the brain, it ceases to be something we do and begins to feel like something we are. A person who runs every morning for a year does not merely have a running habit. Somewhere along the way, through hundreds of nights of synaptic consolidation, they begin to think of themselves as a runner. The identity shift is not a single dramatic revelation, but a slow accumulation, each night of sleep quietly reinforcing the pattern until it becomes part of the brain's default expectation of how the body moves through the world. Researchers studying self-concept and behavioral consistency have noted that identity-level beliefs are among the most powerful predictors of long-term behavior, more powerful than motivation, more durable than willpower. And while the formation of identity is extraordinarily complex, involving culture, memory, emotion, and narrative, the sleeping brain plays a role that is easy to overlook. Each night, as the hippocampus replays the day's experiences and the cortex weaves them into existing networks, the brain is not merely storing what happened, but integrating it into a coherent story of who this person is. The habits you practice become the evidence your sleeping mind uses to update that story. If you spent the day choosing patience in difficult moments, your brain rehearses that pattern overnight, and over weeks and months, patience becomes not just a choice, but a trait woven into the fabric of your self-model. If you spent the day reaching for distraction in moments of discomfort, that pattern too is faithfully consolidated, and over time it shapes how you expect yourself to respond. There is no malice in this process, no judgment. The sleeping brain is simply an extraordinarily diligent librarian, filing every repeated experience into the section of the archive labeled "This is who I am," building your identity one quiet night at a time. And so we arrive at a question that is both scientific and deeply philosophical. If sleep is the process by which our repeated behaviors are transformed into the automatic foundations of identity, then the hours before sleep carry a weight we rarely appreciate. The last experiences of the waking day hold a particular significance in memory research, a phenomenon sometimes referred to as the recency effect, where the brain tends to prioritize recently encoded information during the early stages of consolidation. This does not mean that a single evening ritual will rewrite your personality overnight, because the brain requires many repetitions, many nights, many cycles of replay before a pattern is deeply embedded. But it does suggest that the closing chapter of each day becomes a kind of seed, one that the sleeping mind is especially inclined to water during the first cycles of slow-wave sleep that follow shortly after you drift off. Researchers have found that learning material reviewed shortly before sleep is often better retained than the same material reviewed earlier in the day, a finding that has been replicated across studies of declarative memory, motor learning, and even emotional regulation. The implication for habits is subtle but meaningful. The routines you practice in the final hour before sleep, whether they involve reading, gentle stretching, breathing exercises, or simply reflecting on moments of gratitude, are presented to the sleeping brain at precisely the time when consolidation machinery is most eager to begin its work. Over weeks and months, these pre-sleep rituals are rehearsed and strengthened night after night, gradually becoming some of the most robust and automatic patterns in your behavioral repertoire. This is not a promise of effortless transformation, because the science is clear that lasting habit change requires consistent repetition across many days and many sleep cycles. But it is an invitation to consider the architecture of your evenings with a new kind of reverence, understanding that the way you close each day is also the way you instruct your sleeping brain about which patterns deserve to be carried forward, strengthened, and eventually woven into the quiet, steady fabric of who you are becoming. There is one more dimension to this nightly process that deserves our attention before we allow the science to soften into stillness, and it concerns the role of emotion in determining which habits the sleeping brain chooses to prioritize. Not all repeated behaviors are consolidated equally. Research conducted at institutions including the University of California, Berkeley, and the University of Tübingen in Germany has shown that experiences carrying emotional significance, whether positive or negative, tend to receive preferential treatment during sleep-dependent memory consolidation. The amygdala, a small almond-shaped structure deep within the temporal lobe that plays a central role in processing emotion, communicates actively with the hippocampus during sleep, effectively tagging certain memories as more important than others. This means that a habit practiced with genuine enjoyment, curiosity, or a sense of personal meaning is more likely to be deeply consolidated than one performed mechanically or with reluctance. The emotional coloring of the experience becomes part of the consolidation signal, instructing the sleeping brain to invest more resources in strengthening that particular pattern. This is one reason why habits built around intrinsic motivation, the quiet satisfaction of doing something because it genuinely matters to you, tend to be more durable than habits maintained through discipline or external pressure alone. The sleeping brain, in its wisdom, listens not only to what you repeated, but to how it felt when you repeated it. And across many nights, the patterns that carry emotional resonance are woven more tightly, more permanently into the neural architecture that defines your automatic self. There is something deeply comforting in this understanding, because it suggests that the path to lasting change is not paved solely with effort and willpower, but also with gentleness, with finding genuine pleasure in the small rituals of daily life. The sleeping brain rewards what the waking heart finds meaningful. And so, as you lie here now, breathing slowly, you might allow yourself to appreciate the quiet beauty of this arrangement, this partnership between your waking choices and your sleeping mind, working together across every cycle of night and day to shape the person you are still becoming. Consider for a moment what happens when a habit begins to falter, when the loop that once ran so smoothly encounters friction, disruption, or the quiet erosion of disuse. Sleep, it turns out, plays a role here as well, not only in the building of habits, but in their gradual unraveling. Neuroscientists studying extinction learning have found that the brain does not simply delete an old habit the way one might erase a line from a page. Instead, a new competing pattern must be laid down, a fresh neural pathway that gradually grows stronger than the one it seeks to replace. And this delicate competition between the old loop and the new one is arbitrated in large part during sleep. During rapid eye movement sleep, the prefrontal cortex, that region so closely associated with intention, judgment, and the sense of who we wish to become, communicates with the striatum and the amygdala in ways that researchers are only beginning to map. Current evidence suggests that these nighttime conversations help to weaken the emotional charge of the old habit, while strengthening the new behavioral pattern that was practiced during waking hours. It is as though sleep provides a kind of quiet courtroom where the old self and the new self present their cases, and the verdict is rendered not in a single night, but across many nights of patient deliberation. This is why breaking a habit so often feels like 2 steps forward and 1 step back. Each night, the sleeping brain revisits both the old loop and the new one, comparing their strengths, testing their connections, weighing the emotional resonance of each. Some mornings you wake and the old craving feels distant, faded, almost foreign. Other mornings it returns with surprising intensity, as though the older pathway rallied in the dark. And yet, with consistent practice during the day and consistent sleep at night, the balance shifts slowly but perceptibly. The new pattern accumulates strength like sediment building on a riverbed, layer by quiet layer. The old pathway does not vanish entirely. It remains dormant, a ghost circuit that may never fully disappear. But it grows quieter, thinner, less capable of commandeering your behavior without your conscious awareness. And this gradual silencing, this gentle fading, happens most profoundly while you sleep. There is a beautiful and perhaps comforting symmetry in all of this. The habits that define you, the small rituals and responses that compose the texture of your days, are not fixed in a single dramatic moment of decision. They are woven slowly, thread by thread, in the loom of your sleeping brain. Every night, without your awareness, a process of extraordinary sophistication is at work, selecting which behaviors deserve to be preserved, which emotional associations should be strengthened, and which patterns have earned the right to run without conscious supervision. In a very real sense, you are being authored in your sleep. The person who wakes tomorrow morning will be subtly different from the person who lay down tonight. Not because of some grand revelation, but because the sleeping brain has done its careful, invisible work of refinement. Scientists sometimes refer to this as offline processing, a term borrowed from computing that describes operations performed when a system is not actively engaged with the outside world. And yet, the phrase, however useful, barely captures the profound intimacy of what is happening. This is not a machine running maintenance routines. This is the living architecture of your identity being reshaped by the same brain that dreamed your dreams and felt your feelings throughout the day. Each slow oscillation that rolls across your cortex tonight carries with it fragments of everything you practiced, everything you repeated, everything you chose, and everything you resisted. These fragments are sorted, compared, and interlaced with older memories, older habits, older versions of yourself, until something coherent emerges, something that feels, upon waking, simply like you. And perhaps that is the deepest mystery of habit and sleep, that the self which feels so continuous, so solid, so unmistakably yours, is, in truth, a nightly composition, a gentle assembly of patterns refined in darkness. You do not notice the seams because the craftsmanship is so exquisite. The transitions are so smooth that each morning you open your eyes, believing you are the same person who closed them, and in most ways you are, only slightly, imperceptibly, more practiced at being yourself than you were the night before. And now the science is done for tonight. The words have served their purpose, and they can dissolve now like breath on cold air. Your body is heavy and warm. Your thoughts are soft and slow, drifting like light through deep water. Somewhere inside you, the ancient machinery of sleep is beginning its quiet work, replaying the loops, strengthening the pathways, building the person you will be when morning comes. You do not need to hold on to anything. The brain knows what to keep and what to release. It has been doing this for millions of years, long before language, long before names, long before anyone asked how it worked. So let go now. Let the slow waves carry you. Let the spindles fire in their gentle rhythm. Let the habits settle where they belong, deep in the architecture of who you are, quiet and enduring, like stone beneath still water. You are safe. You are becoming, and the night is long and kind and yours. If this gentle exploration of the sleeping mind brought you comfort tonight, consider subscribing so that we can meet again here in the quiet hours whenever you need us. Thank you for spending your night with Let's Learn While You Sleep. subscribe, and come back tomorrow night. We'll be here. Sleep well.